We treat the ground beneath our feet as a permanent foundation, but the Earth's lithosphere is actually fractured into massive tectonic plates. To figure out why these colossal pieces of rock are drifting, we have to trace the cause straight down, thousands of kilometers below the surface. Looking at this cross-section of the Earth's interior, we can see the planet's distinct layers. At the center is a dense, heavy core, surrounded by a thick, superheated mantle, all capped by the incredibly thin outer crust we live on. The core's extreme heat warms the mantle's semi-molten rock. This rock rises, cools, and sinks in a continuous loop. These convection currents act like an underground conveyor belt, grabbing the floating tectonic plates and slowly dragging them in different directions. Every mountain range, ocean basin, and continent we see up here is the direct result of that superheated engine churning away in the dark. Earth scientist W.J. Morgan helped codify this movement into the theory of plate tectonics. The places where these massive plates actually meet, their boundaries, are the planet's active construction zones. When two plates are pushed toward each other, they form a convergent boundary. As massive continental plates collide, the immense horizontal pressure forces the crust to buckle, fold, and thrust upward. This photograph shows the snow-capped peaks of the Himalayas, which were built exactly this way. Millions of years of subsurface collision between the Indian and Eurasian tectonic plates pushed these mountains into the sky. At divergent boundaries, the conveyor belt drags plates apart. A gap opens up, allowing magma to rise from the mantle, cooling to create entirely new crustal material. And at transform boundaries, two plates grind horizontally past one another, locking together and building up immense friction. You can see the physical scar of that sliding in this aerial photograph, showing a long, linear fault line cutting through the landscape. When the locked plates finally slip, that built-up friction releases, causing intense earthquakes. If the Earth is endlessly churning out new crust and thrusting up mountain ranges, why isn't the entire surface covered in jagged, impassable spikes? This panoramic illustration highlights the wide valleys and flat plains that exist alongside high mountains. They are carved by agents of gradation, natural forces that immediately begin attacking landforms the moment tectonic forces push them up. The first wave of this attack is weathering. This is the process of breaking solid rock down into smaller fragments, right where it sits, without moving it anywhere. Extreme temperature swings cause rocks to expand and contract until they crack, or water seeps into crevices, freezes, and physically shatters the stone. Look at the pitting and surface degradation on this classical statue. This is chemical weathering, where rain and oxygen react with the minerals in the stone itself, dissolving it away and leaving behind weaker substances. This illustration shows biological weathering in action. Tree roots grow deep into microfractures in the stone, exerting enough mechanical pressure as they expand to split massive boulders entirely in half. Shattering the rock is only half the job. To actually level a mountain, something has to haul all that broken debris away. That heavy lifting is called erosion. It's the critical second step where natural dynamic agents pick up the weathered material and transport it across the landscape. Weathering breaks the rock, and erosion moves the pieces. Running water and high winds are incredibly effective. A rushing river acts like liquid sandpaper, carving deep into canyons and relocating sediment downstream. In colder climates, glaciers, massive, slow-moving rivers of ice, act like bulldozers. As they advance, they grind down the rocks beneath them, scooping out distinctive U-shaped valleys. Over millions of years, these agents of gradation erase the towering achievements of tectonic uplift to smooth out the planet's surface. We live our entire lives caught in the middle of this geological construction and demolition. By tracing tectonic plate boundaries around the Pacific Basin on this map, we reveal the Ring of Fire, a massive hazard zone where most human-threatening earthquakes and volcanic eruptions occur. The forces that tear the planet down present their own hazards. This photograph of trees obscured by a severe dust storm shows how aggressive wind erosion strips away the fertile topsoil we rely on to grow our food. Along coastlines and riverbanks, the relentless power of moving water can rapidly eat away the land, destabilizing infrastructure and dropping entire homes into the sea. Every grain of sand and every mountain peak is a temporary snapshot of an endless war between internal heat pushing up and external elements wearing down. Humanity exists in the grand balance, riding on a rocky crust that is constantly being built by the earth beneath us and torn down by the sky above.